This is the review for exam 1 on chapters 1 and 2, right? Which opens September 12th. All right. Again, keep in mind the opening, closing dates and times for exams, quizzes, assignments. All right. Exams are only open for a few days. You'll have 90 minutes to take the exam. You'll have one attempt. And then once all the questions are over, I will post the answers for it. Questions will be approximately 20 multiple choice questions, problems, and 5 short answer problems, which for these you will fill in the blanks with text, numbers. Don't worry about grammar too much, as long as you have the process right. These are graded manually by me once the test is over, right? So that's how it's going to be there. All right, so it'll be one attempt, approximately 20 multiple choice questions, and then 5 short answer problems. And the basis are the chapter review quizzes. Chapters 1 and 2 are the basis, and some parts from the lab as far as concepts from that. All right? So it'll open, again, check the time when it opens as far as that's concerned. Make sure you have enough time allocated, because once after 90 minutes, the exam period will end, period. We'll not have extra time beyond that. All right, so that's exam. I'll go over the sections for here from the text. All right, so starting on chapter 1, not much, just basically, section 1.3 on accuracy, accuracy and significant figures. So a question might be something like 4.0020. How many significant figures does this number have? Right? In this case, it would have 1. You could write this as 4.002 times 10 to the minus 0, 10 to the 0. It would be 4 significant figures. That would be the first section. Also included in this is scientific notation. So if we have 3,485, this is 3.485 times 10 to the 3rd, all right? So scientific notation, keep that in mind there. If you're doing it as a text method, since it's very hard using D2L short answer to do this, you can write 10 to the 3rd is the same as 10 little up thing, 3. So this is all, that means 10 to the 3rd. All right, so that's one part. So section 7.1.3 and 4. Let's see here. On section 1.5, I'll right up here. And then, so this is section 1.3 and 1.4. For 1.5, we have units, right? And we have the MKS units, where this is meters, kilograms, seconds, as far as that's concerned. So that's what we're going to be doing here. We're not, sometimes if you want to understand the system better, you convert it back to English, but we're not going to be doing any conversion in this case, right, for the tests or whatever. We're going to be using the MCAS entirely. So that's first part of 1.5. Second part, you should be familiar with the prefixes as far as different units. So starting from the bottom and using picometer is 10 to the minus 12th meters. Nanometer is 10 to the minus 9th meter. And this would be the same for kilogram or whatever unit. Micron, micrometer, mu is 10 to the minus 6th meters. Millimeter is 10 to the minus 3rd meters. Centimeter is 10 to the minus 2nd meters. All right, then we start going up, and I'm not going to get, these are only going to be in the positive direction. Next one, so kilometer is 10 to the 3rd meter. Megameter, now these are all capital letters, is 10 to the 6th. Gigameter is 10 to the 9th. And tera, a lot of you know from gigabytes, terabytes, and so on, is 10 to the 12th meters. Okay? So those are the standard prefixes we'll be using. We're not really going to do anything smaller or larger than that. You can get down to smaller and smaller. Maybe if you want to add femtometer, which is about the size of a nucleus of an atom, is 10 to the minus 15th. So those are the prefixes we'll be using for that. All right, the only other, 1.6 is a little bit on conversion, and this will only be if you're trying to convert mostly metric-wise. So let's say we've got meters per second, 10 meters per second, and we want to figure out how many kilometers per hour that is. Okay? So the way we would do that is we take 10 meters per second times 1 kilometer per 1,000 meters, right? Because these will cancel out, times 3,600 seconds per 1 hour. So this would turn out to be 3.6. This would be approximately 36 kilometers per hour. And that's just one example of that. So you want to figure it or use it, whether it's divide, how do you flip this so that you end up with the meters cancel out and the second units canceling out. That's how you do it that way. So that's one example there of converting units, which you may find useful. And that is going to be it for chapter 1, as far as that's concerned. The only thing you need to keep in mind, though, is also for problems, particularly for the test problems, the short answer problems, you need to make sure if the problem has units, you have the correct units. So this is both of these are units of velocity, as we'll see in chapter 2, but units of acceleration, I'll talk about that when we get to chapter 2. So that's basically all of chapter 1 that may be covered in the test. All right? So I'm going to move on here to chapter 2 then. All right. So chapter 2, and in this case, this is going to be motion in one dimension. So we're either going to be moving horizontally or vertically, but not both at the same time. That's chapter 3 with projectile motion. That'll be on the next test, and it's also with the lab, but that will not be covered on this test. So going into chapter 1, it's chapter 2, part 1. We define average velocity. Velocity is distance displacement over time, change of displacement over change of time. And this will be in generally units of meters per second. So that's the average velocity. The instantaneous velocity, if I have a graph of position versus time, the instantaneous velocity is the time at a given moment, or the slope of this line at this moment. So the slope of this line as it changes is the velocity. This will only be done on a conceptual basis here. So in this case, as the slope would go from positive to flat. So if the slope is flat, the velocity is 0, and then it becomes negative, which would mean it actually be going back the other direction. And it become 0 and then become positive again. So this would be done on a conceptual basis here. If you look at some of the review quiz questions, you'll get a better idea of that. This is also part of section 2.2 and 2.3 when we talk about instantaneous velocity. So the velocity, say, of a speedometer on your car shows the velocity or speed at any given moment you are driving. All right. So that's what we define as velocity, change of displacement, change of distance over change of time. All right, section 2.4 deals with acceleration, which we define as A is change of velocity over change of time. And this will be in units of meters per second, which we write as meters per second squared. So these are units of acceleration. Distance per time squared are units of acceleration. And we talk about, in this case, we define a positive, whether it's velocity or acceleration, we define positive in that direction, negative in this direction. All right. And if you're going upwards, we define that as positive and downwards as negative. The only difference here between horizontal and vertical is that in this case, this is dealing with X, this is dealing with Y direction. The acceleration due to gravity is G, which is minus 9.8 meters per second squared. But for purposes of the problems, you can use G is minus 10 meters per second squared, as I've done in some of the chapter review questions. This is simpler doing it that way for examples of simplicity. All right, we define, so look through that. Also the term of deceleration. What does that mean? I've been through that before. All right, then we're going to have the expressions or equations. And okay, so in section 2.5, I'll rewrite these again. Equations for x direction, y direction. X is x. Oh, b, I should say, sorry. B is b naught plus at. This is equations listed in chapter 2, section 5. In y, v is v naught plus gt, right? So these are both, whether we're going in this direction, for this case, this direction. For here, a is assumed to be a constant. For here, this is acceleration of gravity. All right, then x is x naught plus v naught t plus 1/2 at squared. On the y direction, y is y naught plus v naught t plus 1/2 gt squared. All right, keep in mind, these are not the same, all right? This is doing one problem this way. If we have a case where we're moving horizontally, in this case is where we're just moving vertically. And then finally, v squared is v naught squared. And in the case here, this is the initial position, this is initial velocity, plus 2a delta x, change of position. And for here, v squared is v naught squared plus 2g delta y. So those are the expressions you can solve, and depending on what you are given, if you're given a time, you want to find either the velocity or the position. These two are the best. If you're giving a velocity and you want to find a position and you have the acceleration, this one is probably the best because there's no time involved in either one of these. So that is section 2.5, and I've gone through some examples of that as far as that's concerned. Section 2.6 involves solving problems using these expressions. And I've gone through, again, some examples of that. And then I'll leave those up for a minute. In the meantime, I'll erase the bottom. So example here, as far as what you could do for horizontal direction, is say we've got an object with initial velocity of 10 meters per second and an acceleration a of minus 2 meters per second squared. How far does it travel? When it I shouldn't say that. How far does it travel? Yes. How far does it travel in t equals 3 seconds? All right. We're trying to find x, so we would have x naught is 0, we just take it to be the starting position. X would be then 0 plus 10 V0 times 3 plus 1/2 minus 2 times 3 squared. And that will give you the position. You can calculate, figure out the answer for that. So that would be the case there. An example in the vertical direction of using G, and let's say we throw a ball upwards of 20 meters per second, and the question would be, and we would be, if we throw it from, let's see, throw it upwards, what is its, at time equals 2 seconds. What is y, and how fast is it going? Let's just try that. So we take a ball, we throw it upwards at V0 is 20 meters per second. I'm going to use G is minus 10 meters per second squared. So in this case, I'm trying to find y and v, so I'm going to be using two different equations for this. In the first case, v would be V0, which would be 20 plus minus 10 times 2 seconds. All right? This would be 20 minus 20. It would be actually stopped. So when you throw it upwards, as we'll see that, if you throw it upwards at 20 meters per second, after 1 second, it actually be going, V is 10 meters per second. Then after 2 seconds, V would be 0. Well, then what happens then? At that point, let's look at what happens after 3 seconds. So instead of 2 seconds, try 3 seconds. How fast would it actually be going? After 3 seconds, that would be 20 plus negative 10 times 3 would be minus 30, which would be minus 10 meters per second, which would mean it's coming back down. So it rises to the top. So after 1 second, it's going 10 meters per second. After 2 seconds, it's stopped. On its way back down, it would be going minus 10 meters per second. And then, as you could guess, after 4 seconds, so if you try 4 seconds, then that would be minus 40. It would be going minus 20 meters per second. All right, so that would be its speed, velocity after 4. So it would be start at 20, goes 10, stops, becomes minus 10, minus 20. Question would be after 4 seconds, where is the object again? So let's start it with the first part of right? So we want to find what would be y after t equals 2 seconds and t equals 4 seconds. Okay, so we're going to do both cases here. So y is going to be y0, and that would be 0 because it's assume we're on the surface, plus 20 times 2 plus 1/2 times minus 10 times 2 squared. That would be equal to 40. Let's see here, it's minus 5 would be so it'd be 20 meters high. This would be 40. 2 times 1/2 of 10 is -5 times 4 gives us 20, right? All right, that's for 2 seconds. If we have 4 seconds, then y would be plus 20 times 4 plus 1/2 times -10 times 4 squared. A little room down here. This would be 80 plus 1/2 of that. That's -5 times 16. That would be -80. It would be 0. It would be exactly back to where you started. So you throw it up for 2 seconds and comes back down. And if we had time, if you kept going and we didn't have the ground to hit, it would just keep going faster and faster and faster as it accelerated downwards. All right, so that's basically all of chapter 2. Last thing here, just to summarize on section 2.8 is if we look at graphs, x versus y. Just an example, the slope, x versus t, I should say, not y. X versus t, the slope is velocity. And for a velocity versus time graph, the slope is the acceleration. So depending on where it is. Now if you have a straight line, the slope is constant. If it changes, the slope here may be positive. In this case, it'd be 0. And then if it came back down, this would be negative. So you'd have a positive slope, 0, negative slope for that case. Depending on where you are. So depending on what time you are in this case. So in this case, it'd be getting faster, stop for a little while, and then go back the other direction, accelerating. So that is chapter 2, as far as that's concerned. That again, the exam, which will start on September 12th. If you have any other questions, feel free to email me. But again, keep in mind, the opening, closing